Hello everyone, welcome back to the channel. Today I want to talk about something that almost every growing engineering teams eventually considers microservices. They sound scalable, they even sound modern, and honestly, they sound like the correct next step. But here's something we don't hear enough. Most microservices don't fail because of traffic. They fail because teams underestimate what it really takes to run distributed systems. So in this video, I want to break down why that happens and what nobody really tells you before you split your monolith. So let's begin. Microservices looks very clean in diagrams. Nice boxes, clear boundaries, independent service. It feels organized. But complexity doesn't disappear when you split the system. It just moves. Instead of managing complexity inside one code base, you now manage it in service communication, retries, deployments, monitoring, and network behavior. Microservices don't remove complexity. They shift it from code structure to a distributed coordination. And if you are not ready for that shift, the system actually becomes harder to manage, not just easier. So it's not just a technical upgrade, it's a lot. A lot of teams treat microservices like that way, but they are not just technical, they are organizational. If your team is small and your product is still evolving, a monolith is often faster and simpler. Microservices start making sense when the team grows, ownership becomes clear, and independent deployments becomes necessary. One idea I really want you to remember: microservices scale teams more than systems. If your team maturity isn't there, splitting services will amplify confusion instead of solving it. If we move further to our next slide, the distributed monolith trap. So, this is a very common trap. You split your applications into multiple services. It looks distributed, right? But services still depends heavily on each other. Deployments still requires that coordination between each other, which sometimes becomes complex as well. Now, instead of one complex application, you have multiple tightly coupled applications talking over the network. You have built a monolith over HTTP, and you have added latency and more failure points to it. That's not scalability, that's distributed system. So let's see some real world lessons. Let's talk about real companies. Uber scaled into hundreds of services, but debugging became incredibly hard. A single request could pass through multiple services before failing. They had to invest heavily in tracing and observability just to understand what was happening. Amazon Prime simplified parts of their distributed architecture because it became unnecessarily complex and expensive. The lesson here isn't that microservices are bad, it's that unnecessary distribution increases operational burden at most of the times. But now let's look at something even more interesting. So I'll open a Netflix tech blog website. So let's quickly look at something interesting. So this is the Netflix tech blog. Netflix runs one of the most distributed architectures in the world. What's important here isn't just that they use microservices, it's how much they invest in reliability. You will see discussions around chaos engineering, services failure, scaling challenges, and a lot. The key takeaway is this: microservices at this scale requires extreme operational maturity. They don't assume systems aren't fail. They assume failure is normal and they design for it. Pause slightly. Now let's open one specific example. Scaling LLM post training at Netflix. So this is a recent Netflix article which says that scaling LLM post training at Netflix, how they do it. At first look, it looks like an AI topic, right? But this is really a distributed system story. Scaling LLM post training means coordinating compute clusters, storage, pipelines, monitoring, and failure recovery across multiple services, basically microservices. Notice something important. They focus heavily on infrastructure coordination and reliability. That's the real engineering work behind microservices. It's not just splitting services, It's building systems that are designed to survive failure. And that's the part most of the teams underestimate. So, if I go to our next uh, real world example, which is AWS. So, I'll open the AWS well architected framework. So, now look at this. There is an entire pillar dedicated to reliability because in distributed systems, failure is not rare, it's expected. Their emphasis is fault isolation, recovery strategies, monitoring, and graceful degradations. They are not aren't advanced optimizations, they are foundational requirements. Here's something important to know. A monolith fails loudly, right? A distributed systems fail partially, and partial failures are much harder to detect and debug. Microservices are not difficult because of code. They are difficult because they demand serious reliability engineering. So you can go through this AWS article about it. If we switch back to our slide work, one of the golden rule which you need to understand and which you can take away from this video as well is start simple, design modular from the beginning, split services only when real constraints demand it, and evolve intentionally. And then do your measure and improvement things later on. The best architecture isn't just the most advanced one, it's the one your team can operate confidently and reliably. So, microservices don't fail because they are flawed. They fail because they adopted without readiness. If this perspective helped you think differently about architecture, considering subscribing, and in the next video, we'll explore another real system design topic. Thanks for watching.